In this video, we're going to start section 3.2. We're going to talk about synthetic division. First, let's give a quick summary of where we've been and where we're going. In section 3.1, we learned how to graph a quadratic function. For example, y equals x squared minus 7x plus 6. It turns out that if you change this polynomial just a little bit, if you change it from x squared to x cubed, then graphing the function becomes quite a bit more complicated. So this is what we're working toward over the next 3 sections. In section 3.4, we're going to graph the cubic polynomial. In section 3.3, we're going to find the x-intercepts for the cubic polynomial. And before we do either of those, we need to learn a technique called synthetic division. Synthetic division is used to divide polynomials. For example, in just a few minutes, our first problem will be to divide x squared plus 5x plus 9 divided by x plus 3. Before we get to synthetic division, let's review long division that we learned in elementary or middle school. So let's have a quick review of long division, and then we'll go on to the new topic, the synthetic division. So, for example, if we had 22 divided by 3, we could also write that as a fraction. It means the same thing, 22 divided by 3. And then if we want to work that out, then we make a little house and we put 22 inside and we put 3 outside. And then we ask how many times does 3 go into 22, and the answer is 7. And then we multiply 7 times 3 to get 21. We put the 21 underneath the 22, we subtract, and there's 1 left over. And so the first way you ever learned to write this answer was to write 7 remainder 1. 7 remainder 1. And then you learned that you could also write the answer as a mixed number, 7 and 1/3. 7 1/3. And today, when we get to the polynomials in just a minute, what we'll want to do is we'll want to write the answer like this, 7 plus 1/3. 7 plus 1/3 is the same as 7 and 1/3. And so what we've just said is that 22 over 3 is equal to 7 plus 1/3. And so then there's some good vocabulary that we should remember now. The 22, when we divide two numbers, the 22 on top is called a dividend, and the 3 on the bottom is called a divisor. On the other side, I think these terms are a little more familiar. Do you remember what the 7 is called? It's a quotient. And the 1, we just said it, is called the remainder. And you see the 3 underneath, well, that's the divisor again. And so the divisor shows up on the left and the right side. So we'll try to remember this vocabulary as we go along in the division in the division problems to come. So synthetic division looks a little bit different than long division, but it should also remind us of long division, and they have some similarities too. So let's go ahead and start this first example. Let's divide two polynomials, and let's just remember dividend and divisor. Okay, so what we're going to do is we're going to start out with the house the same way as before, but instead of writing x squared plus 5x plus 9 underneath the house, all we need to do is put the coefficients for each term. And so we're going to start with the leading term, x squared, and the coefficient is 1. And then the next term is 5x, the coefficient is 5. And then the last term is the constant 9. So all we need to do is write 1, 5, and 9. It's not the number 159. It's three separate terms, and to emphasize that, we want to make sure there's enough space in between each of the digits. For the divisor is x plus 3. We don't need to write x plus 3 out in front. Actually, all our divisors are going to be of the form x minus k. So we're not going to see x squared or x cubed or some other power of x in the denominator. We're only going to see x to the first in the denominator, and then there will be a constant after that. And furthermore, the coefficient on the x is always going to be 1. And so when we have this special type of divisor, then all we have to write is a minus 3. So we take just a second. So we take the constant in the denominator, the plus 3, and we change the sign, and we put a minus 3 out in front of the house, if you will. And so now our division problem is set up. And so now what we're going to do is we're going to skip a row, skip a space, and then draw a line underneath. And then here are the steps. We're going to start with this 1, and we're just going to bring it down every time. And then what we're going to do is 1 times negative 3 is negative 3. And then we're going to add down the column. 5 plus negative 3, or 5 minus 3 is 2. And then we're going to repeat that process. So we're going to do 2 times negative 3 is negative 6. And then 9 minus 6 is 3. And that's our answer. Now we just need to know how to interpret it. And so the key is to first pull off this last number and know that that's the remainder. And then everything in front of the remainder is the quotient. Everything in front of the remainder is the quotient. And so now we're going to write our answer just like we did in the example up above. So what we're going to do is we're going to say that x squared plus 5x plus 9 divided by x plus 3 is the same as. And now we want to write this quotient. Of course, we've got to get that quotient back as a polynomial. And so we need the variable x, and we need to have the right powers on each term. And so the trick is to know that the highest power in the quotient is 1 less than the highest power in the dividend. So the dividend started with x squared, and so the quotient starts with x to the first. And so x to the first with a coefficient of 1 is Here, let's go ahead and write it out one time. 1 times x to the first. And then after x to the first is just the constant power, which is 2. And so there's our quotient, x plus 2. And I guess if we feel good about 1 times x to the first, then maybe we can just go ahead and simplify that right here and just call that x plus 2. And then we're going to add on a fraction at the end. Remember, the numerator is going to be the remainder, and the denominator is going to be the divisor. So we have x plus 2 plus 3 over x plus 3. Let's just label the different parts of the answer one more time. So the x plus 2 is the quotient, 3 is the remainder, and x plus 3 is the divisor that came from the problem. Okay, one more thing I want to do is I want to convince you that this really is true, that the expression here on the left really is equivalent to the expression here on the right. How could you check your answer? How could you make sure that it really is true? Well, what if we took our answer and we just added it all back together? So what I'm saying is, let's take x plus 2 and add 3 over x plus 3 to it. In order to add fractions, you need a common denominator. Let's see here. We could look at x plus 2. We could think of x plus 2 over 1, right? And then the denominator over here is x plus 3. So the common denominator would be x plus 3. And we would just write x plus 2 times x plus 3 over x plus 3. So we rewrite the first part, the quotient, x plus 2. We rewrite it with the common denominator, x plus 3. How do we do that? We multiply by x plus 3 in the numerator. And then we're going to add on 3 over x plus 3. Now we have a common denominator, and so we can just add the two numerators together. We'd have x plus 2 times x plus 3 plus 3 all over x plus 3. And just one more thing, let's go ahead and multiply this out. In the numerator, we get x squared plus 3x plus 2x is plus 5x, and then 2 times 3 is 6, plus 6 plus 3 over x plus 3. And then you have like terms 6 and 3. You can put those together, and you can write your answer as x squared plus 5x plus 9 over x plus 3. And sure enough, that's exactly what we started with.